On is our peach breeding program has been going on since the early 60s, and of course we focused on a number of different types of peaches, and now we're focused on fresh market type peaches after we terminated our baby food breeding. RosBREED is very interesting because it allows for the first time some inclusion of molecular techniques, particularly to give a precise identification of the phenotype or the form. What exactly is this peach? What is this? Is it a cling or a freestone? Is it melting? Is it non-melting? And exactly what genes are involved in expressing those traits. In our Arkansas program, we have a combination of melting flesh, quite a big investment in non-melting flesh, which was derived from baby food or processing peaches. And then we have one, if not another, firmness gene that we're not sure exactly what it is, that came from one or two sources that have been included, and it's particularly present in our white flesh peaches. They are freestone and have a crisp flavor, and they soften right at the end of their when they're fully mature. Some would call that stony hard, and some would say, though, maybe it's not stony hard. And what we've done is hybridize a lot of these different types so that we don't know if it's the same gene or if it's different genes involved in what we call their allelic makeup exactly. Well, what's the genetic basis for that? So this project allows us to work in that area, and it's the peach breeders here are working right now with two genes, the flesh type and also sweetness, or peaches vary greatly in the sweetness, anywhere from 8 or 10% to up in the mid-20s soluble solids. So the RosBREED project helped us focus on that. Parallel work that we started now, which is associated with our RosBREED work, although it's not part of the funding of it, but deals with post-harvest storage. We've got firm type peaches which can stay on a tree longer. The idea is it'd be riper and handle better, but we never really carried that through to storage to the point of like, yes, this peach stores better than, let's say, a melting flesh freestone. So the first thing we need is a protocol to be able to store these peaches and see how these new developments work. And that will help identify which ones may have some expanded use for fresh market production and deliver an edible peach to a consumer in a retail market. And that's ultimately what we're after. We do a similar thing with blackberries in that we do storage of the fruit. We store them usually for a week, and we measure the leakiness, turning red, soft, mold. And that's how we identify these blackberries, which are now become commercial standards for the blackberry industry for shipping because they hold up. 20 years ago, most blackberries didn't. So that's all part of this. What's the end goal? To have a product that people enjoy eating. If you get people enjoying eating fruit with a smile on their face, everybody working back in the opposite direction is going to benefit.